Ask him, where's Chris at? What's he doing? What's happening? What's going on? Been MIA for a bit now. Had a lot of things going on behind the scenes. Got a new print room up and running, new workshop area, and also to deal with some rehab. Some of the stuff people know that I've had a bit of an injury in the past. That's the reason I got into 3D printing. So I just had to get on top of that. Had a bit of aches and pains I had to get on top of it. So a bit of physio, a bit of massage, a bit of, bit of treatment there. So we're all good. Yeah, so we're back to it now. This video is going to be part 3 of the Orca series settings, setup and how-to tutorials. And this one's all about how to set up your profile settings to suit your models to get the best quality prints that you can get. Now, I understand that not every profile is going to be exactly perfect for everyone's needs. That's why you have to learn how to adjust your settings to suit every individual model. You can't just put in a setting and just say, yep, bang, that's perfect for every model. It does not work that way. A lot of big YouTubers will turn around and say things like, oh yeah, the default settings are fantastic. The guys over at, Frankie Builds and all that sort of stuff. Do you honestly think they're going to give you their exact settings? Otherwise, if they are, they're going to enable you guys to, be able to print the things they're printing. Now, that's going to take away from what they're actually doing, not only in their channel, but on their business as well. And I get that. You have to keep some things to yourself. But for me, I'm not about that. I'm about making sure that we can all learn from each other and we can all improve to create better print qualities so that we can get better prints out of our materials and the money we throw into our printing to save us in the back pocket from the rigmarole of failed prints and getting the quality we want and not being let down by the quality we're not getting. So let's dive into it. Let's not waste any more time. This is going to be a big video. Well, when I say big, it's going to be a long video. I'm going to try and put some timestamps in. So if you want to skip ahead through that, you can. We're going to start off with the profile settings, the basis, and what adjustments should be made based on each profile setting you need. Whether you're going to be on standard 2.0, whether you're going to be, going 0.6 right up to 0.8 millimeters for fine detail. So let's jump into it. Let's go into it. Let's see what we need to do. Let's dive into it. I'm going to cover probably, let's say 70 to 80% of the settings. Why is it 70 to 80%? Well, the other 20 to 30% is generally just, really, really high-end technical adjustments that you don't really need to worry about at this point in time. We'll cover that at a later date, but this is going to take your print levels, a level of printing, I should say, to the next level. Let's go. All right, here we are, guys. We're in the Orca Slicer now. So here we are, the part 3 of the profile settings, how-to tutorial for pro tips and tricks. So what we're going to do today, as you can see, I've got 6 plates. Why have I got 6 plates? Well, this is just to show some random selections of, different types of models and shapes to give you guys an understanding of why it's important to fine-tune your print settings in your profile settings. Whether it's Orca Slicer, Prusa Slicer, it generally flows across. I mean, generally the settings are a little bit similar in most slicers, whether it's Cura, Orca, and even, the new Creality Print 5.0 is a little bit of a, a spin-off of Orca / Bamboo Studio. So you're going to find a lot of those settings, although they'll be different locations, they are very similar in that way. So in the settings. So anyway, so we've got the 6 different types of, STL files. As you can see, I've got the dragon here, crocodile, the dragon's on the left-hand side, the crocodile down here, the flexi croc, and we'll probably start off with something like that. It's a little bit more intricate, so you can get an idea and understanding of how to basically select the best settings that it's going to enable you to have not only less cleanup and less post-processing with your final prints, but also to basically have an accurate print that looks clean, and it's basically as detailed as possible as you can get out of an FDM filament printer. So where do we start and what do we do? All right, so what you want to do to start off with is you want to select basically just to create a fresh profile from the start. You want to basically go into the user presets for your printer. Now I'm using the K1 Max. I can, change it and use a CR10-SE, Ender 3s, K1Cs. I've got a variety of different printers to utilize there. It all depends on what type of printer you've got. There is a little bit of a difference with Core XY printers and bed slingers. I'll go into that a little bit later. I am going to put some timestamps in so you can skip ahead if you want to know something specific, whether it's supports, whether it's layer line width, whether it's adaptive layer heights, whether it's speed adjustment, top surfacing. All those things I'll put in as timestamps so you can jump ahead. So from the start, here we go. So we'll start off with select 0.2, which is your standard print height for a 0.04 nozzle. And you want to start off with this sort of side of it. So you got your layer height. Now most people will just say, oh, let's leave this alone, it's fine. All the default settings are fine. And the people who say that, well, they're not really telling you 100% truth, because it does actually make a difference. So why do I say that? Well, the first layer, especially with intricate parts, if you look at the crocodile down here and we'll zoom in on it, is very important, because if you look underneath, you've got a very small contact area on the build plate. Now, what does that mean? Well, you want, if you have that first layer height too high, then what's going to happen is you're not going to have the best adhesion between your lower layers as they build on the first few layers as they go up. Now, why is that important? Well, because with intricate models that have very fine details in their prints, like this one does here, you want to make sure that those very small points on, say, for instance, the claws and the bottom of the tail and the structure of the footprint, you know, is that you get that adhesion between those first couple of layers to be really, really strong and very, very tightly sequenced together. Now, to do that, if you're going to do a really fine detailed print, you're probably not going to do it at 0.2 layer height, although you can, but with a fine print like this, you will get some layering in the top surface, especially when you come to the cylindrical, or say the circular areas or curved areas of your print. As you can see, I'm highlighting it with my mouse there. On top of the actual bridge of his snout there, or, you know, skull region, you'll have those problems in, you know, in the legs and feet. So how do we avoid that? So what we want to do is we want to adjust things like the layer height and the first layer height. So for me, if you find that if you've got a base pattern with some nice thick lines like this, you can generally just leave that at 0.2. If you do have some areas where you have very fine pointed areas or very fine small supports for a small print, you can adjust the layer height, so you get a multitude of smaller in height layer lines on the first few levels of layers of your print, so that you get better adhesion on the bottom layers. Now, to do that, you just simply remove the 2, and we're going to make that, say, 0.16, or you can even go 0.112. Now, this is not going to affect your overall print time in general, as the first few layers you do will always be slower layers, and that's important because we want to have a greater adhesion and we want to have more accuracy on the base of our print. You know, especially with flexi models, you want to have a lot of accuracy on the base of your print, because that's going to formulate the structure for the print, not only to adhere on, but obviously the base foundation for each individual print component that is then movable once it's complete. So I would probably stick with, say, 0.16 on that one. And the layer height for something like this, if you wanted a crocodile print and you wanted it, you know, like a flexi print, and you want it really highly detailed, you don't have to go right down to 0.8. I would probably just go to 0.12. That's probably more than enough. And why don't you really want to go to 0.8? Well, with 0.8, you are basically applying that layer height to every single layer of the print. Now, there could be, you know, there could be 800 layers, there could be 1200 layers, there could be 400 layers. You know, it depends on the height of the print and how many different layers of intricate detail there are in the print. Now, you don't want those layers to be the same height all the way through. And why? Well, because if you do, you're going to have an issue when it comes to each top surface layer of the print, as it gets to, say, the top edge of the spine area of the bone. You're not going to allow that print to modify its height so that you get less ridge lines between the end tips of every single junction of the print. And that's important because that creates more detail. So how do we fix that? Well, there's another option you can include in that. It's called adaptive layering. And that's it there, right there. Now, generally, when you first open this, it's going to say something like 0.50. And what is 0.50? Well, basically, that's the largest height variant that you will actually get within your layering that will enable you to print a thicker or a finer print. Now, with a 0.4 nozzle, you can only get a maximum of 0.5. I mean, I've tried 0.55 mil. It's not that great. So what we want to do is we want to bring that down. Obviously, we've got a 0.4 nozzle. So my advice to you, you can bring it down as low as you want, but I generally like to do about 0.29. 0.29 seems to give me really good fine quality prints. And then you've got this different radius. So the 5 higher or lower decreases and increases the curvature and the radius that the print can actually smooth that filament out. So when I press adaptive, you'll see on the right hand side here, we have a whole bar across here. Now what does that bar do? Well, what that bar represents, represents the layering outside of the normal height of the print that we've selected. So this black line here represents the 0.12 or 0.12 millimeter layer height. Anything left of that is down to 0.8, and anything to the right of that is all the way up to the side, to the right, is up to 0.5, or sorry, 0.29 as we've selected in our adaptive settings. So if I was to quickly go out of that to give you a point of reference, and I was to say select, this is a really good model to show you what I mean. So let's select this. All right, now without touching any settings whatsoever, we'll change this and we'll go 0.12. Now I'm not going to select anything. I'm just going to make sure supports are off. Everything's good. And we're not going to change absolutely anything, and we're going to click slice. Now we're going to slice this. Now it should do it pretty quickly. And what you're going to notice is it's going to print every single layer, apart from the first layer, obviously, which is done at 0.2 of millimeters. It's going to print every layer of this expandable sword at 0.12 millimeters. Now, that's going to increase the slicing time frame of this sword model. As you'll see now, it's 80% nearly done. We'll give it a bit more time. It's doing the layering. And we're going to notice in a second, here we are, we've got a total print time here of 4 hours and 23 minutes. So that's not even touching a single setting, and that's using the base profile. And as you can see here, we've got a lot of lines showing up. You know, we've got a seam there we have to change. We've got seams that aren't uniform. You know, down the bottom of the handle here, we've got, you know, some layering issues there. But all in all, we can see we've got some seam issues in between the layers up here as well, but we'll come back to that. The point I was trying to raise is, if you choose to have 0.12 on everything you do, that means even on the areas that are larger than 0.12 of a millimeter, it's going to still print at 0.12 of a millimeter. Now that's going to slow things down. So we don't want to do that. So what we'll do is we'll refresh this. We'll go back to prepare. And what we're going to do is we're going to leave this at 0.2, but we're going to select adaptive. Now, as you can see, as soon as I pressed adaptive, it changed color and went to red. There's some green there, but mostly red. Now, what is that? Basically, what that's showing you is it's showing you what areas it's printing your model at layers that are a height higher than, you know, 0.2. Now, why is that important? Well, basically, it's showing you that even when it prints that other print of 4 hours and 32 minutes, I'm pretty sure it was, it's not going to do a very good job of printing that. And it's going to produce layer lines that it thinks it needs to produce to fill these gaps in between these layering as it works its way up. Now, if you go to the right-hand side of this, you'll see here, as I put my mouse cursor over the bar on this right side table chart here, you'll see that the blue line that follows all the way down, this is the total length of your print. So as you can see, when we go down the bottom here, the green section, and you can see as I float the green section here, you can see when I go up and down, if you look at the model while I'm moving the mouse on the right-hand side of the adaptive scale bar on the right far side of the screen, you'll notice that some little colors on the model, and that's showing you whereabouts we are on the model. So as you can see right there at the top edge of the handle, it's decided that it's going to do is it'll pick the areas that are most square with the most sharpest angles, and it will apply the most detail to that you know, part of the print. Now, that's a bit of an issue with most prints because it's not just the areas we want at 90-degree angles to be our most accurate parts of the print. So how do we fix that? Well, quite simply, what we do is we go up here, and you can see the adaptive setting up here where these three lines are. That's usually set at around 0.50 to start off with. Now, what is that number representing? Well, that's representing the millimeters of depth of layers that you're going to get per layer of filament on your print. So if we want greater detail, you can use this slider here, and it takes you right up to 1 millimeter. Now, we don't want that because the layering will be horrendous. So we want to bring that right down, and I like to choose somewhere between 0.35 and 0.29. So with that said, let's go 0.32. All right, we'll lock that in. Now, what we're going to do here is before we press anything else, you've got two options. you can press the adaptive button, and what that's going to do is it's going to automatically start to smooth out. If you look at the right hand side scale, it's going to automatically smooth out these jagged zigzag up and down movements of our filament layering lines. Now, as you can see, the reason why they're up and down is because this handle on the print itself here that I'm circling with the mouse has, grips or curves in the layering of the handle. That's the system trying to adjust the height to compensate for that filament change in height. But we don't want that because it's not going to make the print as great a quality. So what you can do is you can actually come along, you can manually left click and you can just basically drag that corner in to make it flat, or you can press the adaptive button and it's going to start to smooth that out. Now, the more you press on that, the more it's going to smooth it out. Now, you'll find that sometimes if you press it once or twice, it'll smooth the model out nicely. But what we want to do with a model that's this heavily reduced in layering and this far into the red is we want to bring it back into the green as possible. And the green is basically telling you that it is combining the layer lines together in a lot finer compression layering, so that you see less layering lines appear on the top surface of your print. And that's really important. So what we'll do is we'll left click each one of these and we're just going to run just so ever slightly above, as you can see, up and down, just to bring those edges. Now, we don't have to be perfect, just closer towards the midline of this print. Now, what is this actually doing? Well, what this is doing is actually bringing those areas, as you can see, it's turning white. It's bringing the areas of those layered prints, or those layers, back towards the middle spectrum of the actual layering we wanted, which was 0.2 millimeters per layer from our 0.4 millimeter nozzle, and it's going to basically allow it. Now, this is going to slow the print down a little bit, but you are going to get way better quality because it's not allowing the system just to basically print it as fast as it can print it. Or what the printer slicer actually does is it tries to change the lines automatically so that it can get the best outcome print based off a 0.2 millimeter line width or layer width, without totally, making the print, exceed the value of your adaptive speed that you'd put in there, which is 0.32. Now, obviously, the lower we go on that top number up here on the adaptive quality speed spectrum, the lower we put that number and then press that adaptive button, the more detailed print we're going to get. But that's obviously drastically going to increase our print time. So that's why I always look between 0.32 and 3.5, because on a model like a broadsword like this, which is expandable and collapsible, generally that's going to give you enough detail. If I was to do an intricate model or a small miniature like this little army figurine here, it's a World War II British military model. As you can see, it's quite small in comparison to my fingers. You'd want to be doing that at around 0.22 or 2.5 to minimize the layering lines so that you can get more detail with more smaller prints. But for a larger broadsword like this, you can get away with, say, 0.32. It will give you a really good surface quality. So as you can see, we've really brought these lines back in. Now you can see it's still quite jagged all over the place. Press the smooth button. It's going to, each time you press it, it's going to take those jagged lines that we tried to decrease, and it's going to smooth them out into a constant flow. So you can see there's no more ridges to the right hand side. There are some red spectrum areas, and we can just basically bring the left hand mouse cursor in and we can just touch them up just with a couple of clicks if we want to. And we can also do the same with the bottom, which is going to change, which is working on the bottom of the broadsword. And you can see you've got this green area here which is trying to overcompensate, and we can right click the mouse and we can bring that back as well. So we don't get so we can compensate for, any areas we don't really need it to really go right down to 0.8 millimeters in its layer height. So that's that. So now we press it one more time on the smooth button. And as you can see now, we're starting to really get a uniform color. We're starting to get uniform layering, and we can bring that back a little bit further just by left clicking and sliding down on the higher areas, all the way down, right down to the bottom. And if we left click this again, smooth, we're really going to start to get, now we can almost see no red, and we're basically in the white to a bony orange, I would say. Now that's going to give you some really good print quality. That's going to give you a very even extrusion of layer lines, and you're going to have a much higher quality print. We haven't changed a single setting yet so far in the other aspects of the profile, just layering and adaptive height smoothing. So let's slice this now and see what happens. We had 4 hours and 32 minutes. Now I will suspect that this will give us a slight increase. Well, when I say slight increase, probably an hour or two increase on our print time. I was expecting 6 to 7 hours, and as you can see, we've gone from 4 hours and 32 minutes to 5 hours and 1 minute. And what we've done is we've actually had the whole middle of the handle, right, which was supposed to be a 0.2 layer height. The software automatically put the actual grip section of the handle and was printing the raised aspects of that handle right up to 0.35, 0.4 of a mil, which we don't want. So a lot of the time when people think they're printing at 0.2 millimeters, you're actually not getting 0.2 millimeters. When the program slices the software, it chooses what it thinks will be able to, compensate for speed versus quality. Unless you tell it you want more quality, it will always compensate for speed with quality in second. So that just proves to you what I just showed you there. That without adaptive layering, with 0.2 millimeters, we got 4 hours and 32 minutes, and with just implementing adaptive layering and bringing our layer lines from up to 0.5 all the way through the handle to no more than 0.32 millimeters, it only increased the time by 29 minutes. And that's going to significantly increase the quality of your print, and we only just got started. So that was with one setting, guys, absolutely one setting in total, which is crazy, I know. All right, so moving forward from there, if we come back out of that, remember that was 5 hours and 1 minute. Now we've got line width. Now that's another one we can talk about. Line width, with line width adjustments, the stronger the print you want, the thicker the line width you want to have in place. Now, for a broadsword, obviously it's a expandable sword. You don't want it to break if you're going to use it as a cosplay or a little play piece or an ornament or whatever you're going to use it for. You don't want to just basically flick that sword out and it just basically shatters. You don't want that. So for a broadsword, I would probably keep the settings on that line width about that. I would probably say, though, for the first layer, I probably wouldn't go 0.5 to the left here under line width. I would probably change that and go to 4.5. Now, why am I going to do 0.45? Because if you look at the bottom of the print, you're going to notice there's a lot of layering lines in between each layer of the collapsible and expandable sword. And if we make those lines for the first layer too thick, those first layers being so important to making sure that they don't overlap each other, we don't want it to basically make it so that those lines have any contact with any of the interior lines as it layers its lines outwards or inwards, whichever direction it goes, because that's going to affect the actual sword from operating. So we don't want that. So by just decreasing it by 0.5, that's going to clean that first layer up. Now, if you were doing a bigger model, say for instance you're doing a helmet and most of the base platform was support structures and so on, you would just leave that at 0.5. But for us today, I'm going to put that at 0.45. Obviously, you can see the default layering line is 0.42. I would just change that to 0.4. I know it's not much, but it does make a little bit of a difference. Sparse infill, we can leave that at 0.5. Now, if you do want to use less filament, you can reduce that sparse infill and the internal solid infill, and you can reduce them down to 0.42, and we can make the internal solid infill 0.39. Now that will make it, some will say, oh, that's going to make it weak. Well, it makes it a little bit weaker, but you also get the added benefit, because we're using adaptive layer lines, we're getting a finer reduced height within our layer lines. So because of that, we're getting better fusion on top of each layer we print, rather than having thicker layers just sitting on top of each other that aren't binding as well as a thinner layer that really seats down on top of each other. So that sort of compensates it in a way, so we can get away with that. The next one we've got is seam position. We always generally want this aligned. Sometimes you can play around with it. Now, you've got a new setting in Orca Slicer that gives you the option to have scarf joint. I'll provide an image on that right here. And basically what that does is, instead of having a gap between where the filament starts and stops in your print, and then it basically gives you a line of where the filament joined from its start and end position, what it does, it overlaps the seam in a 45-degree angle so that it joins the seam together, which minimizes the seam, so you don't end up with a seam like this with a gap in the middle, causing a continuous line that stands out and can sometimes ruin the print, especially when you've got gloss, satin, or shiny filaments that you're using. Can make or break the look of the print, especially if you've got a lot of details and there's a few seams. The other one we'll look at as well, we'll just move this adaptive marker, is wipe on loops and wipe before external loop. The biggest one is this one here, wipe before external loop. And what that's going to do is, as it's extruding the outer surface of your print filament model, it's going to basically stop extruding and just run out the remaining part of the filament that's oozing out of the nozzle to finish off that line. And that's really important because that's going to not, it's going to prevent over extrusion. It's also going to prevent blobs and also prevent stringing, because it's going to finish out the melted filament that's currently in your nozzle just to finish off that pathway, which is really handy. You can have wipe on loops, so basically on the inside as it runs round, it can run round and do the loops on the inside as well. It can do the closed section. It can put a bit of a movement there so it compensates and does it on the inside layering as well. That's optional. I've found just wiping before external loops is the best because that affects your top surface quality. So that's that one there. The next we've got from there is our resolution. So you can see the precision there. We've got to 0.12. Our slice closing gap is just up to 0.5. Don't worry about that. You've got arc fitting. Generally, the on, what that's going to do is it's going to provide better sequences and G-coding sent to the printer. That's going to enable you to have better contoured printing. And also the next one we want is precise wall. What that's going to do is it's going to improve the consistency of the software that generates the G-code to detect whether there's a curvature in the wall and adjust the filament extrusion width and profile so that you can get better curvatures to the prints and angles as well for 90-degree bends. Ironing we don't want unless it's a flat portion of the model. You could turn around and implement ironing on this edge surface inside here, which is basically just by putting all top surfaces, but if you do that, then you're probably going to get some ironing on the top end of your round handle, which you don't want that, so we'll leave that off. Wall generator, you've got Arachne and Classic. Now, some people get confused between this. What is the difference between Classic and Arachne? If I said that right. Well, basically what the difference is Classic will give you consistent extrusion lines within your wall, and Arachne, what that'll do is it'll automatically work similar to adaptive layering height lines that we adjusted earlier, but what it's going to do is it's going to allow the software to generate the G-code file to send the information to the printer to tell it that it needs to adjust the actual width, not the height, but the width of the print lines themselves, to make constant adjustments based on the dimensions of your print model, to allow it so that it has less layering lines on the width spectrum of your model. And that's going to give you better accuracy and better detail on prints that are building up as they come out from the sides and build upwards. So that's really important. So for me, I generally will put that as Arachne. It is the newer way of generating layer lines within the width of your extruder. And it will give you better detailed prints. If you do want faster prints, however, and you are printing a model that doesn't have as much detail, you can select Classic, and that's just going to print more consistent, not adaptive layer width lines, which you can get away with things that are cylindrical or box typed, models. Whether it's home things like shelves and bowls and brackets and all that sort of stuff. But for most models, stick with Arachne. You don't need to change anything in there. The settings that it's got there is already pre-mapped. You can increase the wall distribution count, but I wouldn't worry about that too much. Walls and surfaces, there's only really a couple of adjustments there. Generally, the wall printing order is really important. You want to have that left at inner and outer. That's the default setting. You can change that to inner, outer, inner, but I would only recommend doing that if you had a model that was, how would I say it, not a character model or a cosplay model or a prop model. I would only change that if it had a square or cylindrical model that had a lot of overhangs. And what that does is it changes it so that it prints the inner layers first and the outer layers and the inner layer again, and that cross hatches the filament on top of each other so that it actually can hold the extruded overhangs in position better. It gives you better bridging, but you do sacrifice a little bit of surface quality because the finer layer is an inner layer rather than an outer layer. So unless you're doing large overhang flat surfaces, I would leave that for inner outer. Print infill first, no, definitely not, especially if you want good top surface quality. And the other one we want to look at is small area flow compensation. Now, if you didn't have this one, this is in the newer version of Orca Slicer 19. It may or may not be the beta one. I'm not sure. You have to check that out. I'll put the link in the description below so you can download the latest one if you need to from GitHub. And what that small area flow compensation is going to do is it's going to just adjust the flow ratio of the nozzle. I don't want to go into too much complication and overcomplicate things as too much, but basically what it's going to do is as it runs out to the edge of your model as it's printing, it's going to allow for the nozzle not to over extrude or under extrude and give you a better inner wall and outer wall infill connection layering without having a rough surface connection, without having those blobs in between your infill and your outer wall printing sequence. And that's pretty much that for that one. After that, you've got your bridging. You leave that standard. We don't need to worry about that. The last thing we'll talk about in quality is our overhangs. Now, you do have an option to make overhangs printable. What that will actually do is it'll actually adjust your prints. So that if you have an overhang that is a very sort of lots of overhangs, for instance, if you go over towards our dragon over here, we'll just click it over here, unclick that one, click him over here, come here, you. So we want this one here. So if you were to select this one here, you can see this one has a lot of different points where it's extruding outwards, overhangs. Although it is a model designed to be able to print with no supports, you do have these little things here, like the little tassels on top of the dragon's head there. Now, you could change that so that you can make overhangs printable. And what that's going to do is it's going to change the dimensional accuracy of the print. It'll take away any sharp corners or any outward or inward trajectory filament printing corners or areas where it sort of shoots out or darts out away from the actual print itself. And what that'll do is it'll change it to give it more of a curvature so that it can print vertically straight up and then around rather than having to just go like that and then dart straight out to print. So that can change it. It doesn't make a massive impact on your print, but I would only use that setting for detailed models like that dragon and stuff like that. I wouldn't use it for a helmet or anything like that. The other one you've got down there is reverse on odd. Now this setting is actually quite important. What reverse on actually odd does is it actually reverses the layering technique of your print. So if you highlight over reverse on odd, you've got, it can also help reduce part warping, and it alternates the pattern of the overhang that it's printing. So what it's actually saying is, as it goes to print the overhang, each layer that it builds up over the overhang, as it comes out, what it's actually going to do is instead of just printing out and then coming back, out and coming out, it's going to print, it's going to stop, and then it's going to print another layer there, like a extensional point, just a little point, and then it's going to come back again. And what that's going to do is it's going to give the filament a little bit extra area to hang on to as it prints that next increased height layer to then extrude a little bit more. And that's going to give you a little bit less stringing from your bridged areas. And a little bit more accuracy when it attempts to bridge outside of an area that it doesn't have support, which is really a really good idea. The software handles that quite well. I've been testing that one for a bit and it seems to work quite well. I'm quite happy with that. You do have the other option that you can utilize for when you're printing PETG, ABS and ASA, PC and nylon and those sort of materials to implement reverse only on external perimeters. And what that's going to do is basically as it comes to the outside surface edge of the model in any direction, it's going to basically change, it's going to overlap a print area of an edge, so enable the the filament not to lift up, especially on your bottom layers from the bed. Now we all know with ABS and ASA it does tend to shrink quite a lot, so that can help with that as well. But for today, we're just focusing on our base settings for PLA, so we don't need to touch that one. But keep that one in mind. That one is a setting that you can utilize for ABS and ASA printing. and I have used that quite a lot when I've done things like the shrouds for the K1 Max, or you've done a devil burner, things like that. That comes in handy for those sorts of structures. Moving on from there, we've got strength. That's pretty straightforward. You know, your wall loops. If you want a stronger print, you want to increase your wall loops. Obviously, it's going to increase your print time. Wall loops will probably increase your print time more than infill, as sparse infill and dense infill layers print a lot faster than the walls themselves. So, you know, if you were printing at 150 millimeters a second, your infill lines will probably be around 250 to 300. Same as if you're printing your lines on your outer walls and inner walls at 250, your infill will be probably printing about 350 millimeters per second. Whereas if you were to do reduced infill and increase your layer lines, you'll find that because the layer lines are the inner, outer wall and top surface of your print, you're going to spend a lot more time printing those areas, so they'll have to be printed slower if you want a better surface quality. So it's a bit of a give or take there. If you've got a model like a helmet or anything intricate where the surface, you really want really good details, I would probably look at, and you're not really worried about time, you know, with a helmet, because it doesn't have a lot of density, you probably just increase the layer lines and just cop it sweet for time on printing. You know, if you're printing a model like the dragon there, the statue, I would probably use less outer layer lines and probably a little bit more infill. You know, that's up for debate. I've had success doing that. I find that works the best. So that's that. So wall loops I generally like to keep for most models around 2 to 3. As I said, if you are printing a helmet, I would probably up that, unless it's just for a display helmet that's not going to get knocked or you're not going to wear it. If you want it to be strong, I would probably up that to around 4. 5, 6, 7 is probably a bit overkill. Even 3 you can get away with. Depends on the material. If you're using PLA Plus, it's a bit stronger, so, you know, is a lot better. But generally 3 to 4 is substantial, and infill I'd probably stick to around 10. 10 to 15 is usually good enough, because considering it does, with a helmet, you don't have a lot of infill anyway. Other models, you know, when you're talking things like usability models, for structural purposes, obviously you want to increase it, but for models, not really. Surface infill, there's a lot of conjecture about that. I generally use gyroid. It's usually one of the faster patterns that has the least issues as far as binding to your layers. I do use grid too, rectilinear if I want a really good mesh print. Gyroid, some say it's the strongest. It's not generally the strongest. It depends on the model and the shape of the model. But generally I would say, you know, gyroid's good for your models anyway, because it's a fast layering print for infill surfacing, and it does really well. And you don't get any rubbing as well, and it's very unlikely to get over extrusion with gyroid printing on infill, so that's great with that. Everything else is pretty standard. You can leave that the same. The one thing I will say though is on top and bottom shell surface areas, I would recommend the top surface you've got is generally mostly set at monotonic line. Now that can be changed based on the model, but I'll leave that for another video. And I always like to match my bottom shell thickness with my top shell thickness. And why is that important? Well, the bottom shell thickness will tell you that if you leave it at 0, it will make the thickness of your bottom part of the print, the way it works out the thickness of the bottom part of the print before it starts not doing layers but then starting to print infill, is it works that out by how many shell layers you have. So if you only have 3 shell layers and 0 bottom thickness, that means you're only going to have 3.2 millimeter layer lines on the bottom before it starts to go straight into infill. Now that means the bottom of your print's not going to be very strong. So what I try to do is I change this to at least 0.6 on the bottom, and that matches the top surface area, because whether it's the bottom or the top of the print, you generally want the bottom of the print to be just as strong as the top of the print, unless the bottom of the print is all supports. If it's not, then you want it to be as strong as the top of the print. Why? Because, well, obviously when you take it off the print bed, you don't want the bottom of your layers peeling away from your model. But also, you know, you want the bottom of the print to look nice as well and have a uniform print layering. So if you have your layers too fine on the bottom, it will also show through your print infill, and you won't get the consistency and the structural toughness in the bottom of your print. So not only do I put that to 0.6 to match the top layering shell thickness, but I'll also increase that to a minimum of 5. And that's going to give us 5 layers on top of a 0.6 millimeter top or bottom thickness to give us the detail layers that we want for our prints, and also allows us not to see the detail of the infill, which is really important. All right, moving on from that. Oh, it's a long one, I know, guys. As I said here, we're in for the long haul this one. Next, we've got speed. Obviously, with speed, this is a very crucial point of your print. Some people will sacrifice speed for quality. It really depends on your print, guys. I've printed helmets at 300 millimeters a second, 400 millimeters a second, and got really good prints. But if you want detailed prints, especially with character models, helmets that have a lot of detail, you really probably should, you probably need to slow that down to around 250 at most for good detail. Now, the settings here, initial travel speed, just for PLA, I would probably leave the travel speed at 100%, because the faster you can get that travel moving to a next coordinate that it starts printing that next part of the base or the next part of that filament that it needs to print for the model, the less oozing you're going to have, which equals less stringing. And then obviously your first layer is a standard. I like to change that to 40, and my first layer infill, I usually go about 85. It's not much of adjustment, but I just find that gives us a slightly slower first layer, gives us better adhesion to the bed, and also slightly accurate as well with less stringing, which is really good. I usually have at least 2 layers for the first few layers, sometimes 3, depending on how many intricate parts that it prints in the first layer, but generally 2 is usually suffice. When we're talking speeds, I don't adjust the overall speeds as much unless you're doing a really small fine print model. But what I will do is I'll adjust the small perimeter speed to 20%, and then the small perimeter threshold to 20 millimeters. Now, that's 2 centimeters. Now, why have I done that? What that's going to do is every single time it goes to print a area that is 2 centimeters squared in height and width, it'll reduce the speed of your print to 20% of the max speed of the actual print itself. Now, what is that working off? Generally, for my tests, I found that to be the top surface print speed, which is 200 millimeters a second. So, with that said, if you're going at 200 millimeters a second and it comes across an area of the print that is 20 millimeters squared in height cubed width, it will slow down to 20% of 200. Well, what's 25% of 200 is 50, so we're going to be looking at around 40 millimeters a second. Now, if you think about 40 millimeters a second, 3 or 4 years ago was what every printer was running just to get details out of a print. So now we can get better details at high speed, but that said, 40 millimeters a second, for instance, for this Dragon here, would enable us today, with the clipper printers we use, to get good details within this print area here. You can go slower if you want to. You can reduce it to 10%. If you have a model like a helmet where you want the magnet areas of the holes to be a little more cylindrical and more accurate, you can bring that down to say 10, and that will also increase the speed of your print because it's having to detect less smaller areas to slow down to print. That makes sense pretty much. So generally I'll leave that at 20, and then that's pretty much basically for speed. Obviously, you have the option you can slow it down if you have access to Moonraker via Fluid or Mainsail, and also via the printer directly. You can reduce the speed if you find that it's starting to print and it's not as accurate. You can slow that down from there. Next, we've got overhang speed, slow down for overhangs. You've got slow down for curl perimeters and classic mode. I generally go with the slow down for curl perimeters, and I find that most important because the printers usually can detect the corners and slows down itself from that, as well as using jerk, which slows down the travel from when it zigzags from one corner to the other. And slowing down for perimeters, I don't touch it, I just tick it. And what that's going to do is you can see from the millimeter settings, it slows down the speeds based on the percentage of how much of a percentage that radius is. So that's pretty much that said. Everything else we leave the same based on what your printer's base settings are as far as acceleration travel, and the jerk settings you leave as well. I haven't had to touch the jerk settings, found that fine. Supports we're going to leave for another video because that's a whole new beast altogether. There's a lot of different options in supports you can choose and configure, and that's really, really heavily dependent on the model you choose. So that's something I'll probably do in part 4, tutorial of Orca Slicer. And, you know, if there's something that you want to see outside of that, or something that I've missed that you really want to, you know, focus on or you're not sure about, just, you know, pop a comment down below and we'll see if we can get onto it for you, or maybe pop another video in there. After this video, we'll be doing the K1 Max maintenance and tutorial video as well. That's been a video that's been highly requested for some time, so I am about to do that as well, so that's good. All right, so skipping off from supports, which we're not going to cover today because it takes too long, is we've got our others, which is basically covering our bed adhesion, prime towers, and the way we're slicing our models. Now, if you're in Cura or Creality Print, the older one, that would generally be under experimental or extras. So for Orca Slicer, it's others. Now, skirt loops, I don't generally do skirt loops, as I find that generally just by using the prime, which is basically running the line it does on the FDM printer as it primes the filament before it starts the print, is usually suffice. It's optional if you want to run a skirt print, which is basically a line around the outskirt of your print. It's entirely up to you. I don't do it. As far as brims are concerned, brims are good if you don't have a PEI bed sheet or a flexi textured bed sheet, and you're using a smooth bed sheet with glue. I'd probably recommend running a brim, or if you're not running an outer brim, I would probably run at least mouse ears, which basically give you little round circles, like little miniature brims on each little corner of the base of your print to not allow it to lift away from the bed. So the mouse ear option is a pretty good option, and it does allow for you to remove those little tabs quite easily, because I know sometimes if you have a brim, it can be a real pain in the ass to print. And also, if you were to go back to the crocodile model here, for instance, if you were to have to remove a brim from this entire area here, if we go underneath, go back out of that, bring that down. If you were to have it to remove a print from this entire area here, you would be here for a long time. It would take, I don't know about you, but yeah, I'll be reprinting for sure. So we definitely don't want that. That is definitely what we don't want. So that's that. So yeah, generally I would go for a flexi print. I would not do a brim at all. Just saying, there has been people that have done that. I've got a flexi print here. I'll show you. I did with this exact same profile. Not even a fine detail profile. As you can see, it come out really well. There's no stringing at all there. That's one of the good prints there. As you can see, little teeth. I'll just shine that up for you. There you go. That really came out nicely. I was pretty happy with that. There you go. So that's that one. So that's one of those flexi prints from that crocodile. Yeah, so I would probably just, with a flexi print, because it's designed to print straight off the base, I would not worry about that at all. Leave it like that. As you can see, there's plenty of contact room. If you're doing something like these eyes that are for a Spider-Man helmet, I would probably do a brim or mouse ears at least. So that just gives you a bit of insight into that. Helmets, you don't really need because you have a lot of supports that help adhere to the bed. So that's that problem solved as well. What else we got? Brim width, you wouldn't really worry about adjusting that. Prime tower enable, I do find to be handy. If you've got a lot of detailed prints like the dragon or the crocodile, or anything that's got a lot of detailed areas where it's printing, the prime tower is handy because what that does is that it basically wipes the residue from the nozzle as it's printing and also beforehand, and that basically allows the nozzle not to have a lot of excess filament build up throughout the nozzle, and it also helps with printing overhangs, bridges, and any detailed areas it starts and stops from, and that's really good to have enabled. So I generally enable that. I find that quite useful. And then apart from that, we've got special mode. It's optional. You can choose regular, even and odd. Leave it that regular as far as I'm concerned, and layering, which is by object, or so you can print everything at once or one at a time. And pretty much basically that's it. So other than that, you got notes. So that's that. So like I said, if there's anything I haven't covered in this video, feel free to comment below. It is a bit of a mouthful, I know. I could probably talk about this for another hour at least, because there is a lot to go through. You can go back into quality. Unfortunately, every model we do isn't always going to be the exact same settings. That's why if you have a look at my left-hand profile here, you'll see user presets. I have a lot of presets, you know, from PETG to ASA, ABS. You know, I have different presets for, you know, this is just in my K1 Max alone. I have different presets for PLA, detailed, you know, silk profiles. Once again, if you're printing silk and things like that, you're going to have slower speeds, especially on your top surface finish, because it's going to show a lot of detail. It really does depend on a number of things if you want good detailed prints, and that is what type of material you're printing, what are you using, what type of model are you printing? Does it have large surface areas or does it have small intricate areas? If it's got large surface areas, you can print it faster. If it's got smaller intricate areas, you have to print it slower. Your overhangs and bridges, and so on. So these are the things you need to think about. Anyway, guys, if I haven't touched on something you're not sure about, let me know in the comments below. I will go over some features above on the text plane up the top there, where you go into detail about these icons up top. If you want any information about that, want me to do a quick video on that one, I can do that as well. Anyway, guys, I hope this video has been informative for you. I've tried to cram as much as I can within this video as much as possible, and I know some people say I talk too fast, and I'm sorry about that. Feel free to slow it down if you need to, or just, you know, backtrack just to repeat a couple of the processes I went through before. Like I said, we're here to all get better at printing. You know, even some of the big wigs there that have got massive amounts of content and followers, you know, they're not all professionals either. They're just doing the best they can, but sometimes they don't want to tell you all the secrets and all the tricks of the trade, whereas I don't really care about that. I'd rather have everyone learn from what I learn and share my experiences, share what I know with you guys to enable you guys to print better, not waste your money, get better success, better prints first time round, and enjoy the success of having good quality prints with your 3D printer, saving you time and money for your printing endeavors. So that's me, that's Chris, I'm out. Tune in next week. I'll be punching out another video for the K1 Max and K1C series, and a comparison video on prints for that, as well as the K1 Max maintenance video. And I've got a new printer I'm doing a review on from a different company that no one's really done. It's a new version from their old version that people weren't happy about. So I'll stay tuned for that one. I can't give too much away. That'll be next week as well. So I'm Chris, I'm out. Hope you enjoyed the video. Comment, like, subscribe, all that jazz. Help a brother out. Let's do this. Let's move forward. Let's bring back practicality, normality, and honesty to the printing network. I'm Chris, I'm out.